All right, good morning, everyone. So today we're back in Module 6 or Chapter 6 in our textbook. Our topic today is factoring trinomials, which is the exact same title as yesterday's lesson. So we're just going a little bit deeper, going a little bit more in depth here of factoring trinomials. Again, the title of our lesson tells us what kind of solutions we're looking for. We're going to be looking for factored trinomials. So we're looking for, remember, factor means multiplication form. So factors of 4, 1 times 4, or factor of 4, 2 times 2. When they multiply together, they create the original expression. So today we're going to be factoring trinomials. So writing polynomials that have 3 terms added or subtracted. We're going to take those 3 terms that are added and subtracted and rewrite them in factored or in multiplication form. So factor trinomials. So more specifically, we're going to factor trinomials of the form ax squared plus bx plus c. So notice it's real nice. It's in that standard form or exponential decreasing form, right? Exponents are x squared, x to the first, and this constant has an invisible x to the 0 beside it. So we're going to make sure all of our trinomials are always in that decreasing exponential form. And you may say, hey, this looks very similar to yesterday. And if you think that, you're absolutely correct. Remember, yesterday, our goal is to factor trinomials of the form x squared plus bx plus c. So what's the one difference? Well, today we're going to factor those that have a coefficient of a. So let's think, what did we actually do yesterday? Well, let me ask you, what is the invisible number beside x squared? In other words, what can I multiply with x squared that doesn't change its value? So think of that multiplicative identity, and hopefully you come up with the value of 1. So this is the same thing as 1x squared plus bx plus c. So notice, yesterday we were factoring trinomials that did have an a value. We just didn't really see it. It was invisible, right? So yesterday we factored trinomials that had an a value of 1. So the big question is, how do we factor trinomials that do not have an a value of 1? Well, here's the nice news. We're going to use the exact same strategy that we used yesterday. Remember, there are 2 main types: trinomials that could be factored and trinomials that could not be factored. So let's just do a little reminder or review here, because we're going to use the exact same strategy. So if you were absent or if you had some questions with that homework, right, let's double check this. Let's say we have x squared minus 3x plus 10, and you're asked to factor the expression. So given x squared minus 3x plus 10, we are asked to factor the expression. So if you recall, we would factor the leading term. So x squared is equal to x times x. And then we said, hey, we need to factor 10. And that was real important. So we went over to the side and we said, what are all the factors of 10? And that's 1 times 10 or 2 times 5. We write them in least to greatest order. 1 times 10, 2 times 5, 3 times, nope, nothing, 4 times nothing, and you hit 5. So you know you're finished. That way you're not guessing and going in circles. So list those out, least to greatest. And now we're going to look for a pair of factors that, yes, multiply to give us 10, but more importantly, they add, subtract, they have a summation of negative 3x. So think about 1 and 10. 1 plus 10 gives us 11. 1 minus 10 gives us negative 9. What if 1 is negative? So negative 1 plus 10, or negative 1 minus 10. Again, no combination of 1 and 10 will add or subtract to give us a negative 3x. So we can mark that off. And now we look at 2 times 5. And this looks pretty nice. So factors of 10, 2 times 5. All right, remember, we're going for that upside down rainbow. So multiply the inner terms, x times 2 gives us 2x. Multiply the outer terms, and that gives us 5x. So we want a positive 2x and a minus 5x. Again, small minus large. So 2x minus 5x gives us that middle term. So we've met our goal there, that the factors add or subtract to give us negative 3x. But remember that final piece. This is where I said a lot of students want to skip. You got to check your signs back to that original term. Swing those to the right. So positive 2, negative 5. What's a positive times a negative? And a big red flag comes up. Positive times a negative is negative. It does not equal positive 10. So our second goal has not been met. But again, 5 minus 2 would give us positive 3. The other factors didn't work. So our hands are tied. 2 times 5 also does not work. So if you remember, this trinomial or second degree polynomial cannot be factored. In other words, x squared minus 3x plus 10 is a prime polynomial. So x squared minus 3x plus 10 is prime. And that made some of you nervous during your homework and in class, and that's okay. They are different. So here's a little motivation. We're going to learn how to factor and deal with these in Module 8. So hang with us a couple more weeks, and we will learn. Because remember, why do we factor these? What's the big interesting application? Well, the fun ones are when you kick that football, how much hang time does it have? At what time will it hit the ground? How far has it gone? So we want to learn to factor so we can start solving equations that tell us about time and height. So I have a lot of fun with the sports and applying these. So we got to build our bank of skills here. So we're going to make one small change here. Again, we want to really be good at this strategy. We're going to use it for all of our factoring today. So we've got x squared minus 3x minus 10. Again, keep x squared anchored and factor it. You have x times x. That's real nice. Factors of 10, again, look for those factors. You have 1 times 10 or 2 times 5. We know 1 and 10 don't add or subtract to give us a negative 3, but 2 and 5 look really nice. So we say that's 2 times 5. Multiply the inner terms, that's 2x. Multiply the outer terms, that's 5x. So again, we ask ourselves, how can we add or subtract these to give us a negative 3x? And again, that's negative, so we want small minus large. So positive 2 minus the larger number. So 2x minus 5x is negative 3x. So there's our first goal met. And now you got to really swing those signs to the right and check. Do they multiply back to give us what we want? So here we go. Positive 2 times negative 5 does equal our goal of negative 10. So we have found two factors that add or subtract to give us negative 3x and multiply to give us negative 10. So we know that x squared minus 3x minus 10 can be factored. Now here's the part that made a lot of you laugh in class, but we went circle, circle for the first factor, circle, circle, and then box, box. So we thought of this as the upside down rainbow method. Circle, circle gave us the first factor. Box, box gave us that second factor. And again, commutative property. So this is equal to x minus 5 times x plus 2 as well. Now, we're very confident in our answer that we have x plus 2 times x minus 5 as our factored form of the expression, or multiplication, multiplied form of the expression. But again, I'm going to beg you, right? When we think we found an answer, we're going to try to check our work. So just set it up here. We think the answer is x plus 2 times x minus 5. And the only way here is to use that distributive property. Multiply every term in the first binomial with every term in the second binomial, or the second expression. So x times x gives us x squared. X times negative 5 is that plus negative 5x. Go back, we're going to multiply the 2 now with every term in the second binomial. So 2 times x gives us positive 2x. 2 times negative 5, gives us negative 10. We'll combine like terms. So we have x squared minus 3x minus 10. And we look at this and say, hey, this equals the original expression. So we have factored correctly. So at this time, you can be confident in saying, I have found my answer. The factored or multiplied form of the trinomials is x plus 2 times x minus 5. So you're thinking, that's pretty good, but we did that yesterday. Well, again, we really want to be awesome at this strategy. We're going to use this strategy now when a does not equal 1. So let's go with a nice beginning one here. All right, we're going to factor when we have prime values. And then once we get good at that, we're going to factor when they're composite numbers. So we're going to factor 5x squared plus 7x plus 2. All right, we love primes because, hey, there's only one set of factors. 5 factors as 1 times itself. So again, we can go ahead and factor that with confidence. We have 5x times 1x. And now 2 is 1 times 2 or 2 times 1. I write out both options because this is no longer x times x. So the order of our factoring here with the 2 actually matters a little bit. So I'm going to now use a pencil in case I need to change my answers and check it out. So I'm going to go ahead, draw my little factor tree here. So my factors of 2, well, I'm just going to try the first pair out. So 1 times 2. So 1x times 1 is 1x. 5x times 2 gives me 10x. 1x and 10x, will they ever add or subtract to give us 7x? No. So I'm going to cross that pair off, and I'm going to keep the 5x and 1x in place, and I'm only switching out the other factors here of 2. So I'm now going to try 2 times 1. That's my only other option. So I've got 2 times 1 instead. And now let's look and see what happens. So multiply the inner terms. 1x times 2 gives me 2x. Multiply the outer terms. 5x times 1 gives me 5x. And this is looking really good. Can I add or subtract this combination in any form to give me 7x? Absolutely. Positive 2x plus positive 5x gives us positive 7x. We've met our first goal. And now let's double check those signs. Swing the signs to the right. Positive 2, positive 1. So 2 times 1 equals 2. We've met our second goal. We found a pair of factors, 2 and 1, right, that multiply to give us the constant. And when multiplied with the leading factors here of our first term, they added or subtracted to give us that middle term. So we'll go back to the silliness here. We're going to say circle, circle, and then box, box. So my circle factors are 5x plus 2, and then I'll box, box, and that'll create that second factor of 1x plus 1. Again, you can use the commutative property, so this is equal to x plus 1 times 5x plus 2. So notice we used our exact same strategy. We factored the we factored the coefficient. That 5 was 5 times 1, so 5x squared is equal to 5x times 1x. We factored the 2. 1 times 2 didn't help us out in the middle, so then we tried 2 times 1. And we were able to find a combination that was able to create our middle term, as well as multiply back to give us a positive 2. So 5x plus 2 times x plus 1. And again, to be confident, we're going to check our work. So 5x plus 2 times x plus 1. So use that distributive property. Some of you like to call it FOIL, which is okay when it's a binomial times binomial. So we've got 5x squared plus 5x. Now go back, multiply by the 2. So we have a 2x plus 2. Combine like terms, 5x squared plus 7x plus 2. Indeed, this does equal the original expression. So we can say, hey, 5x plus 2 times x plus 1 does in fact equal 5x squared plus 7x plus 2. So we can go ahead and box that solution there. All right, so we're going to practice a couple more of these. Here's one other dramatic type. All right, and you may chuckle a little bit with this one. We're going to factor 4x squared minus 4x minus 48. And this one hopefully stands out to us. All three real numbers here are multiple of 4. So we can lead off by saying, hey, this is the same thing as 4 times x squared. Negative 4x divided by 4 leaves us with minus 1x. Negative 48 divided by 4 leaves us with minus 12. So the trinomial is equal to 4 times x squared minus x minus 12. So again, I would recommend here just bringing down that 4. All right, and then you can factor and go ahead and set up these pairs. So why not you give this a shot, see what you can do. So go ahead and pause the video. Okay, hopefully you did pause it. You came up with those factors of x times x, 4 times 3. All right, multiply the inner terms, we get 4x. Multiply the outer terms, we get 3x. We can add or subtract these to get a negative 1. That's positive 3 minus 4. So small minus large here to give me that negative 1. And then swing those signs to the right. Negative 4 times positive 3 gives us negative 12. So circle, circle. There's my x minus 4. Box, box to give us x plus 3. So those are our first main two types with a coefficient that is not equal 1. In this case, a equaled 4. So we're now going to look up at the board and we're going to try working a couple of these together and get a couple volunteers to post some of these. But again, if you're unsure about presenting on the board, you know if you use that distributive property, you can check your answer. So let's go ahead and give some of these on the board a try.